Hello, Maurieo! Land surveying, meaning the faces, face left, face right. So yeah, in this video I'm going to look at a pretty common thing that we used to do in the field book days of meaning the face left and face right. Now once again, this is something that I've been doing for quite a considerable period of time, so it just comes quite naturally to me, and was quite a surprise to me when I found that explaining this to my students and things, they sort of didn't get where I was coming from, and it wasn't until I realized that, hey, you know, you've been doing this for 40 years, it just comes pretty natural that perhaps it needs a bit of closer examination. So yeah, you know, let's go and have a look and see what we've got. So first of all, why measure on both left face and right face on an instrument? Well, one of the main reasons why we do this, of course, is because it eliminates quite a number of different inaccuracies that might be very small inaccuracies that might be present in a total station, sort of the way that it can affect the your horizontal bearings. It might be reading just a little bit off. So the difference between faces gives you a bit of an indication of collimation error, and also obviously when you're doing your vertical angles, difference between faces there can give you a bit of an idea of where things are. Typically these days we have quite accurate instruments that are digital instruments, and they can be have quite significant sort of differences. Well, they don't have any difference at all, so any significant differences, obviously we might send them off for surveying, and you know, usually we just measure things on if there's not so much error. For a lot of our work, like we might measure on just the one face, just left face being the main one, where we set things true. So here we have, just in here, just as by way of an example, we have a little round of bearings here to add ITMM, and to you know, a number of Travis marks and a couple of pegs. And you can see here you've got your face left and your face right. And what we do is we mean the face left and face right degree, the minutes and seconds, and then we usually retain the degrees from the face left reading, which is usually set to true. So you can see here this situation, you've got a number of different situations that arise. So here you've got 15 minutes, so they're both in the same minute, 16 and 38, so we just mean the 16 and 38. Effectively, by taking the mean, we're going halfway between them. This one here, a little bit trickier, because we've got 32 minutes 54, and then it goes through 33, and then for another 16. So meaning that one's a little bit trickier. And then this one here is similar again, where you've got different minutes. This one here, you've got a whole different degree going on. So you've got 301 0027, and here 129 59 54. So you've got to be extra careful there. And we've got the mean here, down in here, 301 0010. And then this one here is just a fairly simple one. The idea also of the orientation correction when we're doing a round of bearings. So the bearing from ITMM to iron spike 4 was 163 15 20, and that was our back bearing that we were trying to set. But because these instruments are quite accurate, in that a second is a very small division, and also that we have these various small errors or collimation differences between the faces, it's almost impossible to set it exactly at 163 15 20. So we set it as closely as we possibly can there, and then we do that. So there we've done our left and right face, 15 16, 15 38, and we've meaned it. Halfway between them is 27. I usually go to the nearest second, so don't worry about points of a second. So what we've got there is a bearing of 163.1527, but we wanted to set 1520, so we've gone 7 seconds too past, so we've got to take the 7 seconds off. 163.1520 gives us the 7 seconds right in here. So we wanted that, we got that, so we've got to take 7 off. Now, because this is an orientation thing, if we take that off there, we've got to take it off all the others, because the distances or the angles between these or these directions are all in terms of each other. So if we orientate the whole thing, the first one by flicking it around or subtracting 7 seconds, we've got to do that to all the others in way of orientating the instrument. So the orientation applies to all of the directions. Now let's just have a little closer look at meaning these here, and as I said, there's two situations. The first situation is where both values are on the same minute. So here you've got some known degrees, and you've got 14 minutes 28 as your left face, and then you've got here some degrees 14:56 as your right face. So they're both on the same minute. So, and there's coming up to 15 there, 14 is back here. So this is where you are. So you've got you can see there that you could, on this case here, there's a couple of ways of doing this. You can add the seconds, they're both on the same minute, so that's 28 plus 56 is 84. 84 divided by 2 is 42, so that would give you a mean of some number, 1442. Alternatively, you could look at between 28 to 56 is 28 seconds, so it's 28 seconds from there. So you could halve that, which is 14 seconds, add that on to the 28. So that's 28 plus 14 is 42, plus another 14 is 56. So where they're both on the same minute, it's pretty easy. Just add them up and divide by 2, or work out, go halfway between, whichever is easiest really, it just depends. Now then we come to the more harder situation where the values are on a different minute. So here, say for instance, we've got something 38 minutes, and we've got a left face of 38:23, and then we go something 39 minutes, and then our reading here is 39:47. Okay, so we want to go halfway, but in the meantime we're going past this one here. So what we can do there, well, one way of doing it is to go 38. There's 37 minutes up to 39, and then 47 minutes past it. So 37 plus 47 is 84. Half the 84 is 42, and then we must add that to the 23. So 23 plus 42 is 65. And so that's bringing us into 39:05. We're just coming that little bit past there. 37 plus 05 is 42. Okay, and 42 and 47 in there, and 42 from the 5 going through. So you can see it gets quite complex. So just quickly, 38:23 is 23 past there, and there'd be another 37 up to the 39, and then another 47. 37 plus 47 is 84. Half that's 42, and then that must get added on to the 23, which brings us to 65, and the 65 is 5 seconds past, so 39:05. So you can see why it's always a good idea to have your left face and right face readings quite close together if you possibly can. Send it away for servicing. You don't want too big a difference, because it's way easier to take the means for a starter. So yeah, so you've got to be a bit careful about this. So yes, so there we are. a little bit of an intro into taking the mean of the face left and face right bearings. Do be careful where you've got one on 1 minute and another one on another minute, so you're going from 1 minute into the next. Remember also that it is the same as time. So if you, like for instance, want to know how many minutes from 11:45 to 12:10, obviously 45:15 up to 12 plus 10, 25 minutes. So it's just the same as time. It's degrees, minutes and seconds. The degrees, treat them the same as you would hours, except for hours it's either 12 hours if you're working on that system, or 24, whereas with degrees it's 360. So it can only the degrees can only have a value between 0 and 360 when we're in surveying and when we're dealing with bearings. So I'm hopeful that that'll give you some explanation and a little bit of an insight into a simple survey concept that you can have a bit of a look and get your head around. Remember that practice, and after about 40 years it just comes naturally. Cheers, see you.